A big part of Calc 1 is average rate of change versus instantaneous rate of change. This says here's a volume equation for some gallons of water pumping into a tank that starts draining it, okay? So it goes up for a while and goes down. That's not that important. Where V is volume in gallons and T is in minutes. And it says find the average rate of change from, and when you have closed intervals, it'd be from 2 minutes to 3 minutes, from 2 minutes to 2.5 minutes, okay? And then it says starting at 2 minutes, lasting 0.1 minutes. Well, everyone, this is just a different way of having this closed notation. All right? That's just a different English. Now, here's the thing. You could do this, everyone. You could go V of 3 minus V of 2 all over 3 minus 2. You know the top is in gallons, the bottom is in minutes. That's the average rate of change, guys. But the problem is you have all of these things to do. And you do that for all of them. Typically on a calculus test, they give you enough of them that you need to set up the formula. And you have to visualize the picture. You don't need a picture for this one, but I did draw one. What we have is a parabola. And here a blue curve is shown over on the right side of the screen here. And what we have going on, guys, is at some point P, A comma F of A, and then later on the curve, some point Q. And I'm looking for the slope of this secant line. All right, that is the average rate of change between P and Q. If you make the rise over run of it down here, the little triangle, it becomes this formula, which we should recognize, right? And this is not a derivative because we're not taking the limit, because there is an actual H in these. So because there's 3 cases, I am going to do this on this function so that I have an equation for the average rate of change. So I'll come back over here, and I'll work on one side for a second so you can see both. The volume equation was 7t minus 2t squared plus 400. First thing I gotta do is, instead of f of a plus h, it's v of a plus h minus v of a, right? But I'm not going to write that. So it's 7 times a plus h minus 2 times a plus h squared plus 400 minus, and I'm going to put in parentheses so we don't lose the signs, 7a minus 2a squared plus 400 all over h. Guys, blue curve on the right is the function, so we expect every term in the numerator that does not have h to cancel. Does everybody agree? So we got to expand it. I'm just going to write this. This is something in calculus you better have memorized, right, guys? That a plus h squared is that. So I'll distribute in red. 7a plus 7h minus 2a squared minus 4ah minus 4h squared plus 400. Oofta. Now distribute the negative. Negative 7a plus 2a squared minus 400 all over h. And I don't have to write limit because we are not finding instantaneous. What cancels? Negative 400, positive 400. Plus 2a, negative 2a. Negative 7a, positive 7a. Does every other thing have an h? Awesome. I probably didn't screw up. All right. I'm not going to go through algebra here. Factor an h out of each term and cancel the bottom h, which leaves you with this beautiful, 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 beautiful equation. All right, listen carefully. This equation will give the average rate of change starting at A, lasting for a duration of H. Yes, nice catch. Thanks, Connor. Wow. 2 times h squared is 2. You guys are lying to me. Good catch, Connor. All right. You guys agree with that? Does that look better? No, it looks like that. All right. So everyone, all this. Listen, I'm going to erase all this because all I need now is this. I'm going to erase all of this stuff, and I'm going to pull that green equation all the way back to the top, so we can see the problem. All right. And this is the formula. This is the formula, guys, that gives the average rate of change. So if I go back to the top in purple, when I look at this, it starts at A. So it starts at 2. What's H? 1. All right, what's this one? A is 2 again. H is 0.5. And everyone, again, on the English here, A is 2. H is 0.1. All right. I notice one thing about all three of these. A is always 2. So I'll plug in just that first. And I can see it's 7 minus 8. So how about negative 1 minus 2H? And now I just have to do the 3 H's. All right. Now, here we go. So it's called little I, little double I, and triple I. So they have some numbers, okay? So we can write some sections on it as we go. We'll go single page. So little Roman numeral I plug in 1 for H right here. Negative 1 minus 2. How about negative 3 gallons per minute? How about Roman number 2? Plug in 0.5. Negative 1 minus 2 times 0.5. Negative 1 minus 1. Negative 2 gallons per minute. Let's do a little Roman numeral 3. Plug in 0.1. Negative 1 minus 0.2. Negative 1.2 gallons per minute. Everybody, what do you think the instantaneous rate of change at 2 is? This. All right, great answer. All right. We have to remember, if we go dual screen just for a second, that if I'm asking for the instantaneous rate of change, the difference here is this. If I erase this, we are going to pull point Q back to point P, which means the limit, you're going to add this notation. Limit as H goes to 0. You want H to become 0. But everybody, that means over here on the green, I can just add that to this. And that means this goes away. And if that goes away, all you're left with is negative 1 gallons per minute as the instantaneous rate of change at 2. Now, here's the great thing. Can I find the instantaneous rate of change at 3? Absolutely, because here it is. Now I have this equation. It's 7 minus 12. How about negative 5 gallons per minute? What if I want to find the instantaneous rate of change at 7? Sure. 7 minus 4 times 7 is 28. How about negative 21 gallons per minute? And this is the thing we talked about. We really want to see that the instantaneous rate of change and the average rate of change come from the same place. All right? All right. Keep practicing. Algebra is fun.